Welcome back, mathematicians. In this video, we are going to look at a property of functions. We're going to find where a function is increasing, decreasing, and constant given a graph. So let's start with defining when a function is increasing. So a function is increasing as x increases on the coordinate plane, y, or f of x, is also increasing. So as x increases means that we're going to read the graph from left to right, and what we're looking for are the f of x or outputs also increasing. So this would be a part of the graph that would be considered increasing. Let's now go to constant. A constant interval looks like this. As x increases, f of x, or the output, is constant, meaning that it doesn't change value. So it's going to represent itself as a horizontal line or horizontal segment. So in this case, it's going to be a horizontal segment, and so that would be a section of the graph where our function is constant. Now let's look at decreasing intervals of our function, and we can define it as saying as x increases, f of x, or our output, decreases. So again, as we read the graph from left to right, what we see is that the output or y-coordinate is going to be decreasing as x increases. So that would be a section of the graph that would be considered decreasing. Now that we've defined each interval, let's go ahead and look at a specific graph and find the intervals where the function is increasing, decreasing, and constant if they exist. So let's start with increasing. So as we read this graph from left to right, as x increases, we can see that the graph is increasing, or the output is increasing, on this part of the graph. We can also see that the output is increasing on this part of the graph as well. Now what we need to do is identify where that exists in the coordinate plane. To do that, we're going to use interval notation in terms of the x coordinates. So this is really important. So we're going to identify an interval notation in terms of the x coordinates. So we will start with negative infinity, and we will go up to the first x coordinate where it stops increasing. So you can see at positive 2, at x equals positive 2, it actually transitions from increasing to decreasing. That transition point is neither increasing or decreasing, so we don't include it. So in this case, we would put negative 2 to finish that interval, and we would use a parenthesis to close the interval. So again, not a bracket because of the fact that we are not including it in the interval. It's the transition point from increasing to decreasing. Now we do have a second interval, so we'll put a union symbol here, and notice that the second interval starts at positive 2, so again we'll put 2 with a parenthesis around it because that's the transition point where the graph goes from decreasing to increasing. And then notice that it starts to increase from 2 all the way to infinity. So it never stops to the right of 2. So again, we're reading these graphs from left to right. So from left to right, it's increasing from negative infinity to negative 2, and then also from 2 to infinity. Now let's look for intervals where it's constant. And what we notice is that there's no horizontal intervals for this graph. So we would put none for that answer. So now let's go to decreasing, and hopefully we can see that it's decreasing between the intervals where it was increasing. And so we will answer that in terms of interval notation, where that's at in terms of the x coordinates. So that will be from the left x coordinate, which is negative 2, to the right x coordinate, which is positive 2. So again, that's interval notation in terms of the x coordinates. And so that is the section of the graph where the function is decreasing. All right, guys, good luck.